So this is a continuation onto 4.3. This is continuing on from the product rule that we learned in this parent chapter, which we learned that if you have two functions being multiplied to each other, you can't just derive one and then derive the other and multiply the derivatives of these individual functions. So you don't get the appropriate result, so we can't do it. So now for the rest of this 4.3 continued, we learn also quotient rule, which if you have two functions divided by each other, so a function divided by a function, you can't just derive the top, derive the bottom, and then divide. You actually have to do a process, which is called the quotient rule. So the quotient rule states this: half the battle sometimes is just understanding what the notation is. But what this is basically saying, and here's kind of a catchy little phrase, is low d high minus high d low all over low squared. So low d high minus high d low all over low squared. And again, that's low d high minus high d low all over low squared. Start low. Alright, that can really mess us up since there is subtraction here. If you did high d low, you're going to get a negative that you don't want to have in there. It's going to mess you up. Alright, so here is all of the rules that we've had up until this point. Here we had the power rule, we had the constant rule, scalar multiple, sum and difference. Unfortunately, the sum and difference did not carry to the product. We can't have something as nice as the sum and difference, so we had the product rule. And then now we're going to have the quotient rule. So these are the only rules that we can use. Don't make anything up. You gotta use these. Alright, so number 9 is use the quotient rule to differentiate is the rules. There is my quotient rule again. So I'm going to go ahead and start this. We have h of x equals, and I am going to start setting myself up to find the derivative of this function. So I'm going to start with low. Leave that low alone. Low. D high. And I am going to rewrite that high, so how about I rewrite up here? We have x to the 1/3 all over x cubed plus 1. And I still haven't differentiated at all, and I'm still not. I'm just going to set myself up. Minus, so there was my low, d high, minus high, d low. So the derivative with respect to x of this thing right here, all over low squared. Okay, so I am going to switch colors now because I'm actually going to start deriving. So here I go. H prime of x then is equal to, we have x cubed plus 1, which was left alone. But this part right here is our power rule, so I'm going to rewrite this as 1, or I'm going to write this as 1/3 x to the negative, and then minus 3 over 3, so negative 2/3, minus, we had x to the 1/3 then left alone, times, and then this right here, this box, I'm going to box this and go off to the side, would be the same thing as d dx, x cubed, plus d dx of 1. So when you do that, what I'm going to have is 3x to the second plus 0, so I'm not even going to write that because I had a constant. Alright, all over x cubed plus 1 squared. Alright, so there was my differentiation. Now we have to simplify this. And so I am going to ignore this for a second, and we're going to do what we were doing with the product rule. We're going to pull out any kind of factor that we can, and then the lowest possible exponent that we can as well. So the lowest possible exponent that I see is x to the negative 2/3. So off to the side, I'm going to kind of do a little work. We had x cubed plus 1 times 1/3 x to the negative 2/3. And normally you would distribute this in, but we're not going to do that because we know we want to pull out that lowest factor. Minus, and then we had x to the 1/3, 3x to the second. Okay, and these right here, I'm going to divide all of that by 1/3 x to the negative 2/3, because that way I have gotten rid of this fraction and I will have gotten rid of these power exponents that are rational. So what happens is this is going to cancel out. What I have left is x cubed plus 1 for this first piece, minus, alright, here's the little tricky part, you have this x to the 1/3 divided by x to the negative 2/3. So this is where you can go ahead and say, well, this is equal to x to the 1/3 minus negative, so plus 2/3. What you're going to just get is x there. So we have x. Alright, so that, I took that with from there and this from here. Now this 1/3, it's 3 divided by 1/3. So 3 divided by 1/3 is the same thing as multiplying, so 9 x to the second. Okay, so we just divided everything by 1/3 x to the negative 2/3, so therefore we have to multiply it on the outside. Okay, so this all goes all over x cubed plus 1 to the second. Now, so sorry, here's that, it equals here, and so now I'm going to go this direction. Sorry, this all equals to, so this is going to be x to the third, right? So I'm just going to lump those together. So now we have x to the third plus 1 minus 9x to the third. So this right here, it is a grouping, but it's all addition, so it doesn't matter what order. So we're going to have negative 8x to the third plus 1. Okay, and then this 3 and this x to the negative 2/3 is going to cross the line, change the sign. So you're going to have 3 x to the 2/3 and then x to the third plus 1 to the second. And that, I would argue, is as simplified as we possibly could get this. Alright, rewrite, differentiate, and simplify. Those are the directions for this one. So I'm going to go ahead and say, well, you know, I can go ahead and do the low, d high minus high to low. So I'm going to do that. Y prime equals low, d high minus high, d low, all over low squared. So that's just going to be 9. So I haven't differentiated at all, but I am going to still rewrite this a bit for myself. So I'm going to use the sum and difference rule right there, that nice convenient sum and difference rule that allows me to differentiate each one of these individually. So there's that, and I'll take 3 times all of it because we had that 3 from our low and then our d high, minus, and then x squared plus 2x times the derivative of 3 all over 9. So again, haven't differentiated at all. I will change colors because now I am about to actually derive. So what this becomes is y prime equals, here we go, we have 3 times, and then power rule right there, 2x plus 2, because I brought down the 2, subtracted by 1. And then here was technically, sorry, I should have actually rewritten the 2 out here. Okay, and then so it would have been 2 times, and then remember the derivative of x is just 1. Minus x squared plus 2x times the derivative of 3 is a constant. Think about the line that you would have. We're trying to figure out the instantaneous rates of change always. Well, that's just the slopes, remember, so this would be 0 all over 9. Right, and so then y prime all simplified out. These are gone because it's multiplied by 0. So we just have reduce here. Here's 1, here's 3. So we have 2x plus 2 over 3. Or, in other words, 2/3 x plus 2/3. Alright, so now I want you to consider this. We did not have to use the quotient rule because the directions were to rewrite. So you could have approached it like this. Y is equal to 1/3 and then times x squared plus 2x as your rewrite. And now this is just a scalar, right? So I'm going to go ahead and pull out that scalar times the derivative of x squared plus 2x. And what we would have been left with is really just this part right here. So you would have 1/3 d dx of x squared plus d dx of 2 by the sum and difference rule. And again, you should pull out that 2. Okay, but you can see here, sorry I'm moving up, this was really a messy video. 1/3 2x plus 1/3 times, and then we would have 2. And you would see that we got the same darn thing. So make sure if you can rewrite it to be something a little bit more simplified, you do. So here is your homework assignment. Disregard the outline that I gave you, the PACE schedule, use this one.